Sum of an arithmetic progression. Sum of an arithmetic progression, we know that for arithmetic progression, we have the terms which are in a series, and the terms when added together, that will give us the sum of an arithmetic progression. So it should be T1 plus T2 plus T3 plus T4, so on, so on, so on, up till we have the value which is Tn, or T1 expressed as A. It can be A plus T2 plus T3 plus 4 up till the last term, which can be represented as L here. So the sum of an arithmetic progression is given by the formula Sn, which equals A plus L, the first term and the last term, A plus L divided by 2 multiplied by the number of terms in the sequence. So to get the sum of an arithmetic progression, we should be having a defined series or a sequence, so that we can say it's Sn, which should be up till the value of n here. So it has to be a finite series. So A is the first term, L is the last term, n is the number of terms in the series. So as Tn, the term formula is equal to A plus n minus 1 times D. For the last term, we can say it's L, which is equals to A plus n minus 1 times D. I can substitute this L by this L, which is expressed in terms of A, n, and D. And I can say that this is Sn, which equals to A plus L substituted by A plus n minus 1 times D divided by 2 times n, or I can say that my answer here is A plus A, which is 2A, plus n minus 1 times D and n divided by 2 here. So the sum of the arithmetic progression, it can be expressed by two formulas. One is Sn, which is equals to A plus L divided by 2 times n, and the other is Sn, which is equals to n by 2 times 2A plus n minus 1 times D here. So these are the two formulas for the sum of an arithmetic progression. Let's do some questions on the sum of an arithmetic progression. Question number 1. The sum of the first n terms of an arithmetic progression, it's the sum of the first n terms of an arithmetic progression is n plus 5n. Part A, find the nth term. And part B, write down the first 4 terms. Find the nth term here. So to find the nth term, the sum is given by the expression which is n square plus 5n. The sum is given by the formula n square plus 5n. So I can get the first term by substituting my n with 1. If I substitute n as a 1, I should know we are talking about only the first term. Therefore, S1 can be equal to the first term A, and that can be 1 plus 5 times 1, which gives us the first term equals to 6. By substituting n as 2, I can get the sum of the first two terms. So S of 2 will be equal to 2 square plus 5 times 2. That gives us a 4 plus 10, and my S2 comes out to be 14. So S2 means it has to be the sum of the first two consecutive terms. Therefore, S2 can be equal to A plus T2. I have the value of A, I have the value of the sum of the first two terms. So I can get the second term from here. So S2 represented as 14, A can be substituted by 6. That can give me my second term, which shall be equal to 14 minus 6, and my T2 comes out to be 8 here. So I have my A value, I have my second term, which is an 8. So I can very well get the D, the common difference, which has to be T2 minus T1 or T2 minus A. which shall be equal to 8 minus 6, which is equals to 2 here. So the common difference is equal to a 2. So because the question is asking for the nth term, so to get the nth term, I can say it is Tn, which is equals to a plus n minus 1 times d, or Tn is equals to a substituted as 6, n minus 1 times d substituted as 2. Tn then will be equal to 6 plus 2n minus 2, and 6 minus 2 is a 4. So the nth term can be given as Tn, which is equals to 4 plus 2n. So this is going to be the nth term for this sequence here. Second part, write down the first 4 terms. We have taken out this first term, which was a 6. We have taken out the second term, which is equal to 8. And also we have the common difference, which is a 2. So being an arithmetic progression, I should say that the terms, they have to be increasing in an increasing pattern by a difference of 2. Therefore, my first term is a 6, my second term is an 8, the third term then should be equal to 8 plus the common difference, which is a 10, and the fourth term then has to be 10 plus the common difference, which is a 12. Therefore, the first 4 terms shall be 6, 8, 10, and then 12. Let's move to the next question. The sum of the first n terms of a series is given by Sn, which is equal to 2n times n plus 3. It's the sum of the nth terms, which can be represented as 2n times n plus 3. We have to show that the terms of the series form an arithmetic progression. So to make the arithmetic progression, to have the arithmetic progression, there has to be a certain pattern of an increasing or a decreasing sequence. So for that, obviously, I should be having the common difference, which is a d. So let's go for the working then. The sequence for the sum is given as 2n times n plus 3. It's the sum equation, 2n times n plus 3. I can substitute n as 1 and I will be getting my first term. So if I do that, this is S1, which is equals to 2 times 1 plus 3. That means the first term then is equals to 2 times 3 plus 1, 4, which gives me an 8. So I can say here that my first term is equal to 8. If I substitute n as 2, I shall be getting the sum of the first 2 terms. So S of 2, that is 2 times 2, n a 2 plus 3, 2 2s are 4, and 2 plus 3, 5. Second, the sum of the first 2 terms then comes out to be a 20. So from here, I can get the second term, and I can say it is S2, which is equals to T1 plus T2. T2 then shall be equal to S2 minus T1. That means it should be 20 minus 8, and the second term comes out to be a 12. Moving on to the third term. For that, I shall be substituting n with 3. 2 times 3 times 3 plus 3, that gives me 6 times 6, or S3 is equals to 36. So I know that S3 means it has to be the sum of the first 3 terms, T1 plus T2 plus T3. I have T1, which was 8. I have T2, which was a 12. I can find T3. So T3 then shall be equal to 36 minus 8 minus 12, or 36 minus 20. T3 comes out to be a 16. So I have to show that the terms of the series form an arithmetic progression. So the series is in arithmetic progression only if there is the constant common difference. So I have my T1, which is 8, T2, which is 12, and T3, which is equals to 16. Common difference is equals to T2 minus T1, and also it can be equal to T3 minus T2. T2 minus T1 is 12 minus 8. T3 minus T2 is 16 minus 12. Both of them, they are giving us the same answer, which is a 4. That means it's the common difference, which is a 4. Therefore, we can say here that the terms of the series form an arithmetic progression that is shown here. Let's move to the next question. Mo has 7 pieces of wood. 7 pieces, that means our n should be equal to 7. Each piece of wood has a different length. The lengths are in arithmetic progression, so there is a pattern that is getting followed. The length of the largest piece of wood is 5 times the length of the smallest piece of wood. Length of the largest piece is equal to 5 times the length of the smallest piece of wood. The total length, if we are talking about the total length, then that means it has to be the sum of all the 7 pieces, the sum of the lengths of all the 7 pieces. That means T1 plus T2 plus T3 plus T4 plus T5 plus T6, and then the last term, which can be represented as L here. Therefore, I can say it's S of 7, which is equals to 630 as given in the question. So we have to work out the length of the largest piece. We have to find the length of the largest piece, for which the equation is given as the length of the largest piece is equals to 5 times the length of the smallest piece. So if we are saying it is the smallest piece, then obviously it means that we are talking about the length of the first piece of wood which has to be there, or the first term in the series here. So Sn, the sum formula, is equal to a plus l divided by 2 times n. So a plus l into n divided by 2. Why am I taking this formula? I'm taking this formula because in this question, we are talking about the first piece of wood and then we are talking about the last piece of wood. So we can relate them with respect to the given equation for the first and the last pieces of wood, which is a plus l divided by 2 times n. We have the sum here, which is 630. A plus L divided by 2. N is the number of pieces, which is 7 in this case, or I can say that it's A plus L, which shall be equal to 2 times 630, and 7 gets in the denominator here, which gives me the answer for A as 180 minus L. So 180 minus L, and then also we have this equation which said that the length of the largest piece was equal to 5 times the length of the smallest. Length of the smallest, as discussed earlier, shall be the first plank of wood, the length of the first plank of wood, which is 5 of A. Therefore, from here I can say it's A, which is equals to L divided by 5. Substituting the value of A, which is L by 5, in this equation, A substituted as L by 5 equals to 180 minus L. I can say it's L, which is equals to 5 times 180 minus L, giving me 900 minus 5L, or 5L taken to the left becomes 6L, which equals 900, and I can say that L shall be equal to 150 centimeters. So this is going to be the largest length for the 7th piece of wood that we have in this question. Let's move to the next question. Megan borrows some money from her aunt. She gives her aunt $10 the first month. So $10 the first month, that means A shall be equal to 10. 12 the second month, that means it's T2, which equals 12. 14 the third month, meaning T3, which equals 14. The payment continues to rise by $2 each month. Now, $2 each month is a constant amount. So for this series, I can say that this $2 is my common difference, which is equals to 2 here. The final payment she makes to her aunt is $48. It's going to be the last term in the sequence, which is going to be the final payment. And this equals a 48. So L equals 48. Work out the total number of payments, meaning it's the n that we have to find out that she makes to her aunt. So if I make it a series, a series here, then I can say it's a 10, 12, 14, so on, so on, so on, up till the last payment that she makes, which is a 48. I know the value of D, it's a 2. I know it's L, which is equals to A plus N minus 1 times D. L is a 48. A was a 10. D was equal to 2. Substituting all these values, I can say it's a 48 minus 10, which is a 38 divided by 2. That equals n minus 1. Negative 1 can be taken on the left so that it becomes a positive. So my answer here comes out to be n, which equals 19, plus 1, which equals a 20. So we can say here that Megan makes 20 payments to her aunt for the loan that she has taken from her. Let's move to the next question. The first three terms of an arithmetic progression are m minus 3, m plus 1, and 5m plus 5. Work out the value of m. So we are given the first term, the second term, and the third term, m minus 3, m plus 1, and 5m plus 5. So from here, we know that the common difference can be represented as t2 minus t1, and it shall also be given as t3 minus t2. Substituting the terms here, I can say it's m plus 1 minus m minus 3, which shall be equal to 5m plus 5 minus m plus 1. Solving them, it's m plus 1 minus m plus 3, which equals 5m plus 5 minus m and a minus 1. M and M gets cancelled. I'm left with a 4, which equals a 4m plus 4. 4 can be taken common. So 4 equals 4m plus 1. 4 divided by 4 equals a 1, which equals m plus 1, or m equals 1 minus 1, giving us the value of m, which is equals to a 0. So this is the value of m that we can have for this question. Second part, work out the sum of the first 10 terms. So sum of the first 10 terms, obviously we have to apply the formula. We have the value of n, which is a 10 in this case, and we also have m equals 0. Sum formula is n by 2 times 2a plus n minus 1 times d. We are given the first, second, and the third terms, in which m was a 0, which we already found in part A. Therefore, the first term is a negative 3, the second term a 1, and the third term a 5. From here, I can get the common difference, and this is going to be 1 minus minus 3, which shall be equal to a 4. I can also verify it with t3 minus t2, and I can say with t3 minus t2, it should be 5 minus a 1, which is also equal to a 4. So the common difference is equal to a 4. Substituting all the values, it can be n, which is a 10 divided by 2 times a, the first term, which is a negative 3, plus n minus 1, that's a 10 minus 1, giving me a 9, times the common difference, which is a 4. Solving it further, 10 divided by 2 is a 5, times negative 6 plus 36, or 5 times 30, that will give me the sum, which equals 150 here. So this is how we can just apply the sum formula to get the sum for an arithmetic progression. So in the next video, we shall be doing geometric progression then.